Hello guys, today I want to cover last year's IB Chemistry HL exams. It was a November session last year. It's paper 1, so let's get started. So for the first question, we need to find how many oxygen atoms. So as we can see, this molecule have 2 oxygen atoms in OH and 8 oxygen atoms in water, so it's total 10 oxygen atoms. So the amount of oxygen atoms would be 0.05 times 10, 0.5, and multiplied by 6.02, it's going to give us 3.1. Next one, what is the change of state? This is B. Condensation is changing from gas to liquid, freezing is from liquid to solid, and sublimation is from solid to gas. So answer B. How many moles of carbon dioxide produced? So the number of moles of ethane is 7 divided by 28 is 0.25, but because it produces 2 CO2, it would be 0.5 moles. For the next question, we can see that the oxidation state +2 is the most stable for this element because it's a very huge increase in ionization energy. So we can just say that we need to add 740 plus 1450, which is gonna give us 2190. For the next question, we can see that those species have equal atomic mass, but they have different number of protons. They have different number of electrons because it's 52 and this is 53 plus 1, so it's 54. And because they have different number of protons but same mass, they have different number of neutrons, so it's going to be D. So for the next question, for example, if it's octahedral field and we have 1 electron, we can excite it to higher energy orbitals, and for this we need to absorb some energy in form of light. So the answer is A. Which elements are considered to be metalloids? So if we look at periodic table, it's though they are along this diagonal, right? And to be precise, it's around here. And this is like upper bound. So those 2 elements are metalloids and the gallium is not. So the option C. For the next question, it's atomic radius. Because if we keep going to the right of periodic table, that nucleus charge increases and electrons are more strongly attracted by the nucleus. So it's answer A. And as we look down a group, of course, there's more electron levels. So of course, atomic radius is going to increase. So the answer is A. Each molecule can be represented by resonance structures. It's option B because we can write it, for example, like this, or we can write it like this. So we have different resonance structures, and for others we don't have, so the option B. For the next one, I will just explain why nitrogen can't form, because it have only 2s and 2p orbitals, and they are all half-filled, and it can't excite one electron from 2s orbital to p because they are already occupied, and it doesn't have free orbitals like phosphorus or arsenic, so the option is C. For the next question, tetraheteromolecular geometry is for particles that have 4 different bonds. It have 3, it have 4 plus 1 electron pair, so it's 5. It have 4 plus 2 electron pairs, so it's 6. And this have 4, so the answer is D. Alloy metal make it more difficult for atoms to slide over. Of course, this would be strength. The next question basically is the bigger the length of the bond, the weaker is the bond. This bond have the lowest length, so it's gonna be the strongest, and this is gonna be the weakest bond, and the option is C. For the next one, we need to get this reaction. So as you can see, we need to subtract reaction number 3, and we need the first reaction with the plus sign because we need carbon on the left hand side, and we need to somehow cancel this water on the left hand side because of the minus here. So we need to add second reaction, and this would be our final answer. For the next question, this is the energy of breaking the lattice, and this is energy of formation of new lattice, if we can say so. So this should be large and this should be small, so the option is C, because we need the maximum, the most exothermic, right? So we need to exhibit as much energy as we can by formation and spend as low energy as we can for breaking the lattice. Question 16, it's going to be option A, because basically a rule of thumb, the bigger a molecule, the bigger is going to be the entropy. So, and this is the smallest molecule we have, so this is the option A. For the next question, we need to remember Gibbs free energy, delta H minus T delta S, and delta H and delta S are molecule dependent, so they can be positive at the same time. But if T is going to be like a huge number, that T delta S is going to be bigger than delta H at some point, and then free energy would be less than 0. So the option B. For the next question, we can see that this is a first order kinetic reaction, and we know that time of the half-life is going to be natural log of 2 divided by the constant, and we can see the half-life time is 10 seconds, so is ln 2 divided by 10, and the rate of the reaction is K multiplied by the concentration in the first order, because it's the first order kinetics, and basically we need to calculate this, and it's going to give us around 0.1. For the next question, so for the temperature we need to increase the temperature, because actually don't need to Vachetterie principle here, because it's not about equilibrium, it's about the rate of the reaction, and increasing temperature increases the rate of the reaction for exothermic and endothermic, so it doesn't matter what is the reaction. So we need to increase the temperature, and by decreasing particle size we make more collisions, and more collisions means higher rate, so the option is A. For the next question, we can see that this is 2 times, and this is changed by 4 times, or 2 squared. So X2 molecule is going to be with second order, and for this part we see that this is changed by 2 times and this didn't change, so it's gonna be 0th order, and the answer is C. For the activation energy we have K is equal A times e to the power minus energy of activation divided by RT. We can take natural log, so it's going to be ln plus minus energy of activation divided by RT, and this is just the linear equation. If we set 1 divided by t as x and ln k is y, the answer is D. For the next question, we need to write the constant. So it's going to be it's going to look like this. Products divided by the reagents, and we need to calculate this thing. And it's going to give us 2500. So the answer is C. For the next question, of course, option 3 works because by decreasing the amount of water by Le Chatelier's principle, the equilibrium is going to the right to compensate for this water. And for the option 2 also works because if we have more chlorine ions, then the equilibrium is trying to get rid of those ions. So again, it shifts equilibrium to the right. And the first one, it doesn't really matter because the concentration is very, very small. So it doesn't change the equilibrium at all. So option C. For the next one, of course, initial pH would be different because strong acid will dissociate more than weak acid. Same for the option B and same for the option D. They are all dependent on this. And the only answer is C. So it doesn't matter, right, what acid we need to neutralize, because at the end of the day it's just 1-to-1 ratio. For the next question, the weakest conjugate basis for strongest acid, and strongest acid out of those is hydrogen chloride. The next question, we need a salt and the acid. So we need an acetic acid and sodium acetate, right? And the only option would be this one, because for this option we will get sodium hydroxide plus sodium acetate. For this we will get only sodium acetate, and for the option A is the salt of a strong base and strong acid, and it doesn't form buffer solutions. For the next, we need Lewis acid and Lewis base, so some species that can donate electron pair and accept electron pair, and out of those, it's gonna be water, because hydrogen have 3 orbitals and oxygen have electron pairs. For the next question, we can see that the ferrum is received electrons, so it became from +2 to 0. So electrons move from chrome to ferrum. And for galvanic cell, the cathode ions is moving toward cathode, so it's going to be option B. For the next question, we can say this is the oxidation state 0, and this is +2, this is +5, and this is +2. So we need multiply this by 3 and multiply this by 2. So electrons are all equalized. Then we see on the left hand side there is 6 oxygen atoms. And on the right hand side we need to add for water, so it's going to be also 6 oxygen atoms. And on the right hand side we have 8 hydrogen atoms, so we need 8 hydrogen atoms there, and the answer is D. So for the next question we need to check if chromium 3 plus can oxidize chromium. So let's write the first reaction. And chromium 3 plus can oxidize chromium only to chromium 2 plus. So we also need this reaction right here. And we will multiply this by 2 and this by 3. And we are going to add those reactions. And because the potential is given for the energy of 1 electron, we can just subtract from 744 minus 0.914, and it will be 0.17, which is greater than 0, so it can oxidize. And for the second part, we need to check this reaction. I'm gonna leave the first one, and I will change only the second one. We need to multiply this by 3 for the equation, but for the potential it doesn't matter. I just need to subtract from 744 0.407, and it's gonna give us some negative value. So it's gonna be option B. For the next question, a molar mass doesn't matter because what matters is the number of electrons moved. Of course, the duration of electrolysis matter and the charge of ion because they are all dependent on the number of electrons we move, and it's gonna change the amount of the product. So the option is B. For the next question, we need to find the isomers of pentane, and the number 3 have 6 atoms, so it can be the isomer of pentane. This is neopentane, and this is isopentane, so option A. So for the next question, we need to find the chiral carbon. Chiral carbon is a carbon that have 4 different bonds, and let's just draw all the molecules. Bromethane looks like this. This atom have 2 hydrogens, so it's not chiral. The second one looks like this, and it has 2 methane. 2 bromobutane looks like this, and this is chiral because we have brom, we have H, we have methane, and we have ethane. And for the next one, it's gonna look like this. And this atom has 2 identical functional groups, so it's not chiral, so the answer is C. For the next question, if of course the rate of the reaction is gonna be, of course we need the excess because the more oxidizer, the better goes the oxidation. And we need to do reflux because again with higher temperature it's going to be higher rate of the reaction, so the option is B. For the next, retrosynthesis is synthesizing a target molecule by working back. So for example, if we have some large molecule, we will break it apart and try to synthesize from it some smaller, simpler molecules, and we will try then to do an actual synthesis, just reverting those steps. Right? The question 36 is so we need to generate some hydrogen, and this is the way, but then we will get a salt, so it's going to be like this, and we need to neutralize this salt by adding some hydroxide, so the answer is A. For the next question, a well-tested scientific idea is basically already a theory, and because it gave an error for one event, but this theory worked for many other events, we shouldn't be discarding this theory, but we should be revising this theory. So the answer is D. For the next question, of course, mass spectroscopy gives us the mass of the molecule, right? The infrared spectroscopy is usually working for carboxyl and hydroxyl groups because for others is pretty much mass, and proton magnetic resonance can show us this aspect because of the signals of different hydrogen atoms. For the next question, through X-ray crystallography, we get the structure of the lattice, and from the lattice we can deduce bond angles. And for the last question, we can see that this is a acidic proton, so it can be methanol. It can be methyl ethanoate because they both don't have this acidic, and ethanoic acid would give us only one signal in this area, right? But we have two signals, so it should be propanoic acid. I hope you enjoyed this video. Leave your thoughts about this exam. Thanks for watching and see you next time.